Hi everyone. Today we are excited to introduce UniMate AI. So you are brand new AI study buddy made just for international students in Australia and all around the world. So we know that study abroad isn't always easy. So international students often face language barriers, culture differences, and the constant pressure for managing multiple courses with a lot of deadlines. So our goal is very simple: to make academic life easier, smarter, and more personalized. So we will start with our MVP first. So focus on key features like material upload and processing, AI chatbot, and after that, we will continue adding more advanced features in the future. So now let's take a quick look at what UniMate AI can do. So students can choose up to 4 courses per semester. Right after uploading materials, UniMate AI can automatically build a 30-week learning roadmap based on your course outline. So you can also upload more materials like lecture slides, notes, or readings, or make each week topic richer and more personalized. We can also have the bilingual RAG Q&A system, so you can ask questions in English or Chinese, and UniMate AI will give you a clear, accurate explanation in both language. UniMate can also create a personalized quizzes and flashcards, so that will adapt to your study progress. So it help you focus on what you haven't been mastered yet and make review more efficient and way more fun. So the next part will be our live demo. So let's walk through how our AI assistants work in real time. So this is our homepage. So guests can quickly take a look at what our platform can offer. So to start using the assistants, they will need to sign up. Users can choose between email sign up and Google One Tap. So we will go with Google. So if it's a new user, Google can automatically create an account and sign them in, so which can create a smooth sign up experience. So once we log in, users can complete an onboarding form, so such as name, university, and faculties. User can choose up to 4 courses, which will help personalize the response later. So next will be the page to upload courses material, but we will skip this for now. So we will show you how it works from the dashboard. And this is our main dashboard. So all selected courses are shown on the left, and the AI chatbot is on the right. So let's ask AI a questions. So what is system networks and concurrency week 2 about? So as you can see, that since we haven't selected the course, the AI will invoke the Find My Courses to call to request our course selection. So we select the course. And then the AI will invoke another tool call named Improve the Materials. So because AI does not have the context for the course yet, so you will ask us to upload the materials. Yeah, so when user upload a file, so there will be some waiting time, typically will be 20 to 50 seconds. This is because behind the scenes, we are not just allowing the file to OpenAI, but also performing extensive data processing. It will include AI referencing, text trunking, embedding generations, and vector searching. So this technical part we will introduce later in the slides. Let's wait for the AI to process our materials. Yep. You can see that. So the AI will give a correct answer based on the file we just upload. So now when we click Go to Course, so we can see the weekly summary for the course. Yeah. And then when we click the calendar, we can also see the weekly event of the course. So our system is fully rendered in real time, and any changes to the user information will also represent it in the UI immediately. Yeah. We can also see that the AI will remember history message from user, so we can ask some follow-up questions. You can see that the AI responds correctly without needing the full context each time. Now let's test another most engaging features, quiz generation. So we can ask, give me a quiz questions about processing, scheduling from the courses, systems, network, and concurrency. So we can wait for. Now you can see that it generates a multiple choice questions with 3 options. We will choose B. And after we click, the AI instantly explains why the answer is right or wrong and how you relate it to the course. Okay, and we can test the Ask AI functions. When we click Ask AI, so you will link the questions to specific course. So the AI will focus only on this context. So we can ask the simple questions, what week 3 about? So because the prompt still can improve, so we can ask a second time. Okay, this time, so the AI will generate the answers related to the selected course. So that's the end of our live demo. So let's go back to the slides and we will show how this technology works behind the scenes.
So in UniMate AI, we made login in simple and fast with Google One Tap. Users don't need to create a new account or remember another password. They can just use their Google account. When they click sign in with Google, Google verifies their identity and sends a secure token to Superbase. Our backend checks whether the user already exists. If yes, they are logged in instantly. If not, we create a new account automatically. It's literally one click and you are in. Fast, simple, and secure.
Our AI uses tool calling to enhance intent recognition. So it can tell whether you are asking a question, or requesting a quiz, or trying to upload a file. Once that happens, it automatically checks the right tool to get the things done. That intent recognition makes the chatbot much smarter. It understands not just what you say, but what you already mean. And that's the real power here. With tool calling, our AI isn't just a chatbot anymore. It's becoming a truly intelligent assistant. So how does all this come together in our chat system? Let's take a look at our architecture. Here, so what actually happens when user send a message? Let's follow the data on this diagram. Firstly, we grab the user's message at the left side, the chat history and any filters you have selected. Using that, we instantly search through our documents with vector search to find the most relevant information from for your question. All of this context is then sent to our API route. We built our chat using our Next.js route instead of our server action, because the OpenAI sends responses as a live stream, which is token by token. And so the server actions cannot handle that kind of real-time data. By using a route, we can stream messages instantly to the UI. So users see the reply appear in real time, just like chatting with a real person. Now, here is the crucial step here, the tool call decision. So AI will ask itself, like, do I need to just talk conversation, or do I need to do something else? If the AI think it can answer the question properly, and there's no need to invoke a tool call, it will follow the node path. So we stream the text back and save the message to our database. But what if the AI finds that user's question is special? So like when you ask for a quiz, or you ask some questions, the AI don't have the context to give a proper answer, then it will take the yes path, triggering a tool call such as a request quiz on our backend, and it will save the result to our database as well. So on the front end, the UI is fetching database updates and dynamically rendering the latest messages. So the architecture makes our chat capable to handle complex tasks. Also, it's creating a truly dynamic and responsive user experience.
RAG stands for Retrieval Augmented Generation. It combines retrieval methods with generative AI models. As shown in the first row, external data is converted into vectors and stored in a database. In the second row, when users ask questions, the system retrieves relevant data to augment the AI's response. The key benefits are access to up-to-date information, fewer hallucinations, and more accurate, context-aware results. Next. Now, back to our project. The embedding stage takes place when a user uploads a file, just like what you saw in the live demo. We extracted two data sources, AI-generated weeks information and raw file text. The text is split into smaller chunks using long-chain text splitters, and each chunk is embedded through OpenAI's embedding API into a vector, essentially a list of floating point numbers. These vectors are stored in Superbase using the vector 1536 data type, which perfectly matching our embedding dimensions. Next. During chat, when a user asks something like, what is computer vision week 2 about? We enter vector search stage. Both the current question and history questions are embedded and searched using Superbase's match documents function. Each search retrieves the top 10 results above a 0.5 similarity score. These retrieved chunks are added as context to the prompt, helping OpenAI generate responses that are accurate, grounded, and relevant to the uploaded materials. Next.
Prompt engineering. A key lesson that we learned was that the quality of AI's output is directly tied to the quality of instructions. This is the core of prompt engineering, guiding AI's logic. It is about crafting precise instruction to ensure we get the predictable, high-quality results every time. To make our AI from ambiguity to precision, we implemented several key techniques. As you can see here on the right, we didn't just ask AI questions, we gave it a detailed operational framework. We gave it a specific role, such as learning AI RAG assistance. We set a clear purpose and constraint scope to keep it focused. And more importantly, we established hard rules, like be strict and conservative, and don't invert the fact. So what is the impact here? By engineering our prompt in this way, we achieved significantly high accuracy and fewer error rates. It was not just a technical win. It was a foundation of creating a more reliable user experience. Ultimately, we learned that the prompt engineering is an essential discipline for building a robust AI application. It is important to notice that since we're developing and learning at the same time, there is a huge potential to refine this prompt even further to make our AI more intelligent in the future.
In this part, I'm going to talk about testing. Code delivery is not just about handing over code or making something work. In a real-world development, ensuring high quality is far more important than just chasing fast delivery. And in our project, we follow the BDD principle when writing unit tests, because it focuses on describing software behavior in a natural, domain-specific language that everybody can understand. And it bridges the gap between the business goals and technical implementation, simplifies testing in complex problem spaces. Well, and we believe tests should act like the documentation. It can clearly describe the responsibility of each piece of code. And we read tests from the users and business perspective, focusing on what the software should do, not how it's implemented. Well, if we're writing a test and feels really complicated, that means the original code isn't clean enough. So good code makes the testing easy and intuitive, so we need to upgrade our code. And when writing tests, we apply the same clean code principles as in production code. So now let's see a real example. Here we have a use course hook, which is used to fetch course data with the SWR, and then we use the BDD style testing. Well, at the next page, we test with the React testing library in action. And the total structure includes a title and some descriptions of different scenarios. And finally, we require every test to achieve 100% coverage and pass successfully. Well, this ensures that every possible behavior is fully validated and every line of code meets a high standard of quality. And that's how we approach testing in our project.
Here's our CI/CD. We use trunk-based development with a protected main branch. Every pull request triggers the pipeline, ESLint, code style checks, TypeScript type checks, unit tests, and an inferior preview environment, so reviewers can click through Storybook and the app before merge. A PR becomes mergeable only when all checks are green and at least one reviewer approves. On merge, we auto-deploy to production, which lets us ship changes anytime with confidence. Since adopting this flow, we've closed 221 PRs with reliable builds, faster feedback, and review-driven knowledge sharing.
During our transition into backend development, our team decided to use PostgreSQL and Supabase as a database service because it provided a clear and more effective way to fetch everything in a single query. But the migration process is one of our biggest blockers. It broke our team process without any tricky logic. The whole team worked together to debug the issue, and we eventually found the root cause, a mismatch between local and remote migration state. For example, a migration file was generated during local environment, but at the same time, Supabase was run as well. In other words, every action was immediately reflected to the remote environment. So some team members deleted the incorrect migration files locally, but they don't know it will cause the mismatch the remote database. Then it will crash. After fix this bug, the project process is back to the normal timeline. This experience taught us an important lesson: never ever deleted migration files manually. Instead, always created a new migration to correct the old one. That's the only way to maintain a consistent and recoverable database history.
Now, I would like to talk about Kanban tickets, which sit at the heart of our agile development process. They capture each piece of our work and keep everyone moving in the same direction. It begins with clarity. Before any ticket moves to in progress, we talk it through with our product owner to refine the requirements. If a task feels chunky, we break it down into smaller, clearer deliverables. That quick discussion turns vague ideas into shared, concrete goals. From there, we make the work visible. Every ticket lives on the same board, so no work is hidden on a private to-do list. If a ticket stalls or someone sees a better approach, the whole team can step in. This transparency cuts silo mentality and keeps our collaboration effortless. To keep momentum, the board protects our flow. When the in progress column starts to fill up, we finish what's there before pulling any new work. The simple zero limit prevents overload and keeps tickets moving towards done. So with refined bite-sized requirements, open collaboration, and balanced workflow, our agile process stays clear, visible, and on track.
Refactor event-driven to server actions. We initially implemented microservice to listen to database event, from upload weeks and message tables, to trigger AI actions automatically. During the development process, we encountered several failures and debugging difficulties. We realized that we could identify these trigger points for these actions. Therefore, we switched it to server actions. Instead of listening to database event remotely, we could directly call this function from the UI when user perform operations. This new architecture provides a better reliabilities, easier debugging, and clear execution flow by providing a direct traceable call path in each actions. And this is the end of our demonstration. Thank you for listening.